Hi, I'm Gracie, and I'm going to be talking about chemical stoichiometry, which is just a step up from basic unit conversion problems. So the main things you need to know for chemical stoichiometry are moles and Avogadro's number. Moles, abbreviated as MOL, are just a unit of measurement. The mass of a given element on the periodic table is in a unit of grams per mole. Avogadro's number is used to convert from moles to atoms or molecules. Depending on the problem, Avogadro's number may be used in a problem referring to molecules or atoms, since that unit is interchangeable. As I mentioned before, masses on the periodic table relate to the moles of a certain element. This can be used as a conversion factor. Additionally, in chemical equations with reactants and products, mole ratios from a balanced equation are used for different conversions. Here's an example of a problem like this. Pause the video if you want to try it for yourself, but I will mention that this equation is unbalanced. So the first thing you need to do is to balance the equation. When I'm doing this, I like to set up a chart like this, with each counterpart of the equation on each side in order. Then I count up what is already there. So we have a 2 subscript on the I, so there's 2 iodine on this side, and only 1 sodium. And on this side, we have 1 iodide and 1 sodium. So our first step in balancing is trying to get the iodides equal. So we can put a coefficient of 2 in front of NaI to counter the I2 on the reactant side. However, now we have 2 sodium on the product side and only 1 on the reactant side. But then it's actually a simple fix, since all we need to do is put a coefficient of 2 in front of the sodium on the reactant side. Now it's all balanced. Now that the equation is balanced, we can use it in the problem. So we're given 12 grams of I2, and we need to find grams of NaI. So you'll start with what you're given. Then you can use mass from the periodic table, and that allows you to get into moles. Notice that I doubled the mass of iodide because of the 2 subscript. Now you can use the mole to mole ratio. From the chemical equation, you have 1 mole of I2 per every 2 moles of NaI. Now you can use the moles of NaI to get the mass of NaI. To get that mass, I just added the mass of sodium and iodide. All of the units cancel, so you're ready to calculate the answer. And the answer is 14.2 grams of NaI. Now here's an example using Avogadro's number. If you want to try it out first, pause the video. So in this problem, we're trying to find the molecules of water. You're going to start with 1 gram of H2O since it's given in the problem. Then you'll convert grams to moles using the masses from the periodic table. Now you'll use Avogadro's number in the conversion. Now you'll use the Avogadro's number conversion. When typing this into your calculator, be sure to put parentheses around the fractions, especially due to the power exponent. All of the units cancel, and you've gotten to molecules, so now it's time to calculate. And there's the answer, 3.35 times 10 to the 22nd molecules of water. That's all. I hope this video helped you understand stoichiometry better. If you need more practice, feel free to book an appointment with me or one of the other tutors. Bye!